Hello, YouTube. This is Sean McBride with,
Kait Moreno.
and today we are going to pick up in our series covering the Rust programming language. What are we covering this week, Kait?
We're talking about enums and pattern matching, which is chapter 6 of the Rust programming language book.
Awesome. So what are your thoughts about the content in this chapter?
It was definitely interesting coming from JavaScript since we don't really have much of either of these concepts. It strikes me as a way to keep your code safe. What about you?
Yeah, the only thing I can kind of think of in the JavaScript universe is, I guess, like TypeScript enums. But like when I kind of think about what those enums can do, it's like almost like a collection of symbols. So I've actually used enums in the C programming language also. I haven't delved super deep into unions and some of those more advanced types. But when I think of enums, it's just like a kind of a collection of different values someone can pass. So Rust is kind of like supercharged all that beyond what I'm used to. It's kind of neat covering this right after structs because it seems like there are quite a few similarities in the two concepts.
For sure. I mean, they definitely look similar. I guess the way I've been thinking about them is kind of the and versus or. So struct is more of the concept of and. You have all of these pieces of data that have to be there, and then the enums are more like an or. So it can be any one of these things.
Okay. So like I guess you could have a struct that's quartet.
For sure.
And then I guess the enum would be different quartets that you could hire for an event, I guess.
Maybe. Or the music that they're reading.
Okay, music
can
they're
only be
reading.
one thing.
Cool. Yeah, so I guess let's talk about how one actually goes about writing an enum. I'm going to go ahead and just paste some code and we can talk about it. So the chapter started out with one of my favorite topics, Internet Protocol addressing schemes. I'm just deeply passionate about that.
Wow. All right.
Because you got the version 4, and then we're running out of addresses, and then the world got together in harmony, and they gripped hands in hand, and they came up with a new scheme, version 6. If only we could all be like the Internet Protocol standards body. I don't know.
All right.
I'm so passionate. I don't know.
Lofty goals.
Lofty goals. Yeah. So we have our enum here for IP addresses, and we have our v4 and v6. And so what could we actually do with that, Kait?
Well, we could use this enum in a function that expects some kind of IP address, and depending on which one is passed in, execute some code based on that.
That makes sense. And since we just have two states of doing this, I feel like if I was in JavaScript land, I'd have something like is version 6 is like true false, and if it's not true, fall back to the version 4.
Right.
But I guess the cool thing is, like, if someday we colonize the universe, we could have like a V8 something. I don't know.
Right. So then that wouldn't work anymore.
Yeah.
And you'd need to use something like a switch.
And those are kind of gross, I guess. I personally kind of like switch statements, but people always worry about fall through.
Yeah, I always hear people say you should always use switch over if else.
Yeah, I think that's kind of a religious debate a little bit.
Is it? Okay.
Yeah, because if you don't have the break inside of the case block, you kind of maybe can do more than you expect. But I kind of think that's a feature a little bit. I don't know. Oh, cool. So we have our different types of IP addresses. And so I remember that in the book, we have these different variants, but beyond that, we can actually put some kind of state inside of these different types.
Yeah, that's what I've seen as the real powerful feature of enums in Rust over other languages.
So how about we trick out our IP address?
Sure, let's do it.
Boom, tricked
wow,
out.
Magic.
Okay, so what's going on here, Kait?
So it looks like this first variant, you are defining a tuple of 4 U8s, and then V6 you're expecting a heap allocated string. So then if you were to use this in a function, you have this type checking kind of built in as well. It would probably be easier to see this if we actually used IP adder.
I think I can do that for you.
Oh yeah?
Ready?
Wow.
Boom.
Look at that.
So what's happening when I just added?
You are accessing the v-fork variant off of this enum and assigning it to the home variable. It's interesting. It looks like the syntax from the other week with associated methods with the double colons.
Yeah, I mean, I guess that kind of gets into the similarities with structures and enumerations.
Right. It looks like you're accessing a method, but I guess that's not quite what's happening. So then if you used home in a function, you could define a function that takes in some IP adder, and you don't have to necessarily specify which kind you're looking for here. It can just be any of that type.
Okay, cool.
And then you'll have to handle that in the function body, but.
So you're saying that home and loopback, they have the same type?
Yes.
But they are different variants, and they have, I mean, their state is expressed kind of differently. How would we account for that in the function?
Well, we'd have to use probably a match to account for each scenario. And I believe the compiler will yell at you if you don't account for every scenario.
Oh boy, that's pretty strict. Okay.
Yeah.
Well, that's neat. I guess let's come back to that. But I mean, one of the things that we kind of were talking about here with this double colon is some of the similarities between structures and enumerations. And there was an example in the chapter talking about different types of messages. And it almost seemed like maybe a Microsoft Paint type app or something, or you could move to a coordinate, you drop a shape or a line or something like that. And each time that you add a stroke or something, that's implemented through a message. And I have some code I want to copy in, and we can talk about it. Okay. So let's, I guess, comment out the stuff up here. So we have two different message types, and currently they're implemented as structures. And here in this do something, we're talking about how we could pass either a v4 or a v6 variant into the same function. And I'm just kind of thinking here, if we have a write struct and we have a move struct, could we accomplish that same sort of behavior here? Or like, if I wanted to have an accept message that could do either a write or a move, would this work?
I don't think so.
You don't think so?
Because you're expecting a move. And I don't think there's a way to say move or write in Rust. I guess you could have a struct with properties that were equal to these structs. So you could have like a message struct with a move property with a value equal to this. And then in your code, you could have like an if-else kind of thing going on. But
that sounds hella inefficient.
it does.
I mean, I guess we could do the same thing where it's like we just kind of glob all the possible state there. So, yeah, so I guess if I were to kind of naively not really understand about enums and have this, I probably would start doing a pattern that's kind of like, and then the compiler would yell at me about not using snake case, I think.
One other thing I just realized about what I said before was that if you did decide to have this one like mega struct with all of these properties, every time you used that struct, you would have to have data in each of those fields because of that and versus or thing.
Okay, so that's even worse then. So I'd have to have some sort of dummy value that I put into.
Right. That would be pretty terrible.
A terrible path. So yeah, just imagine the pain. So then I would have something like this, right?
Mm-hmm.
Okay. Thereabouts?
Yep.
Do we agree that's pretty awful?
I think we could do better.
Okay, we can do better. Okay. I feel like if I had a code review and you saw this code coming from me, you'd be disappointed.
A little bit.
A little bit. Okay. Well, cool. So I guess that's kind of where this enums thing comes in. So we can take our different types of basically structures and turn them into variants on a shared enum. And then because they're the same type, we can pass them into a single message.
Yeah.
All right. So we've got our move, we've got our right, and we have some extra friends.
Looks good. So then on line 43, we're accepting any kind of message, and then we're using this match syntax to kind of decide what to do with each type.
Yeah, so like I know we did match, I think, in our first video, and we kind of just stumbled our way through, and they're like, here's a match. It's got arms. And that's like all we learned. So like, what's going on in this match statement?
So arms are basically each line here, each pattern that you're matching against. So an arm is kind of like a path that you could take. So here we are just matching on the move pattern, so we'll probably need to implement these other ones. But here we're taking in a message, and then if it matches our move variant, then we destructure it. So we're taking out the X and Y values and printing it to the console. And then I guess on line 46, this is kind of the throwaway value here, this underscore. So basically anything else, if we don't get a move message, we're just printing uh-oh.
Okay. So I feel like using this underscore is probably like a lazy rustation kind of move, probably.
Yeah, right. It's like using type any in TypeScript.
Yeah. Okay. That's, yeah. So really, we should like explicitly enumerate all the different variants.
Right.
I mean, one thing that I'm kind of thinking about here is, like we mentioned, switch statements.
Yeah.
And this feels similar. I mean, you don't have that, I guess, fall through thing with the case, which maybe makes this safer, but it feels kind of like a similar use case.
So with match, I know that it goes through each arm, and basically the first one it hits that matches, it executes that code. Like, how are they different?
How are they different? I mean, let me pseudocode here, I guess. So if we had our switch, right, we have a bunch of case statements. Like, imagine we're accepting user input, and like we're doing a text adventure game or something. So if we had multiple case statements like this, and then like something underneath this E, the Q, the W, and the E would all match and execute the same code.
Yeah, right.
And so I think what that means is if you don't have like a return statement or like a break, you like execute every single case statement underneath.
Right. Cool.
So I guess comparing the switch to the match, you have that guarantee that you're only matching on one arm.
That goes hand in hand with like the essence of enums, that it can only be one thing.
Right.
So
good point. Good point. So we're matching and handling just the move. We have our lazy rustation thing here, so we would implement the others. Do you feel like there's anything else we should talk about for enums?
yeah, I think that pretty much covers it.
So it seems like Rust has some different enums that it provides out of the box. Like I think back to our So maybe our guessing game. There was one that was like an okay or an error, I think.
Yeah. I was always confused by where that came from. So I guess the book was saying that for these super common scenarios, Rust brings these enums into scope, so you don't have to explicitly define them.
Mm-hmm.
Yeah.
Yeah, okay. So I've got an example.
All right.
So I am defining a sum variant of the option type, the value 42. And then based on that here, I have a match similar to what we had before. And I'm handling the none variant, a specific instance of the sum whenever there's 42. And then I have my lazy crustacean bailout thing.
Right. So what happens if you don't have this kind of catch-all?
Why don't you delete it and we can take a look?
All right, I'll comment it out for now.
Yeah.
Okay, so the error is sum 0U8 through 41U8 and sum 43U8 through 255U8 not covered.
Okay.
So we're
So,
only
wait.
handling that one number. Does not
So,
like that.
For me to be a legit crustacean, then I would have to do sum 0, sum 1, sum 2, and have like 255 lines.
Yeah, or maybe you could match on a range. I don't know. Seems like this kind of hints at maybe that's a possibility. This is kind of using that range syntax in the error. So basically what this is telling us is that we need to ensure all possible cases are handling, possibly by adding wildcards or more match arms. Right, so this is getting into that kind of safety, these safety mechanisms that I mentioned at the beginning.
And so the wildcard, is that the underscore?
I'm not sure.
Not sure. Okay. So if we
Seems plausible though.
put that back in.
Yeah.
Okay.
All right.
Cool. So I guess it's kind of neat, but if I was just checking for a specific value, it seems like kind of a complicated way to do that. And I know there was something that was a little bit terser, this if-let syntax. So paste that back in.
So basically the idea of like if you know that in your code you're never going to do anything with the value unless it's 42, then maybe that match thing is a little verbose.
Okay. So maybe something like that.
Yeah.
I don't know about you, but seeing like the let keyword and then the single equal sign feels really kind of...
Yeah. At first glance, when I see that, it feels like something's being assigned to the sum U8 value variable in some way.
I kind of wonder, so does that maybe mean we're declaring something like an unnamed variable or something?
Could be.
Could be, yeah. Let's see, does it run? I guess it does.
Cool.
Cool.
Yeah, I could definitely see this being useful.
It feels like we're giving up some of the safety though, because I do think having the compiler yell at you about not accounting for all the different variants is useful.
I don't think it's necessarily unsafe if you don't want to do anything. If it's none, then that's fine.
Well, cool. So I think we have enough to try to do our pair programming challenge here. Are you ready for it?
Sure.
So one thing that kind of came to mind thinking about enums is a problem that's pretty common for learning polymorphism, and it has to do with shapes. Usually there's like two different kind of challenges you do for polymorphism. One of them is like animals and one of them is shapes. And I'm wearing a Magoosh math GRE prep shirt, so let's go shapes.
All right. Yeah, I've seen the shapes example a lot.
What's your favorite shape?
I think I gotta go with triangles.
Yeah, they're pretty cool. So our challenge is to implement a shape enum with two different variants, one circle and one rectangle.
Mm-hmm.
And then kind of similar to what we did with the structures, add an implementation block
Mm-hmm.
and add a method that will either print out the area of a circle or an area of a rectangle.
Mm-hmm.
So circle is equal to pi times radius squared. And rectangle is equal to width times height. And so I guess that kind of brings up a good point, is like the state we would need for the different variants. Like for the circle, we need a radius. For the rectangle, we need a width and a height.
Yep.
Okay, so would you mind getting started with that?
Sure.
I think our variants would probably be like circle and rectangle.
Right, that's what I was thinking. Okay, so circle and rectangle. And then, so a circle would need a radius, right? So
Yeah.
something like that.
Yeah. Okay. So I guess I have a couple thoughts. So we're using, I guess, tuples there.
Mm-hmm.
How about if we had like labeled values?
Yeah, I like that. So instead, do something like radius. That?
Yeah, that looks better than height and width.
Cool.
Okay, cool. I guess one other thing I'm thinking about is like if we're doing this at pi is probably a floating point number, I'm thinking, because 3.14 blah 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 blah.
Oh, right.
Yeah, so what if we did like an F64?
Yeah. And then maybe we want more than 8 for this. We could do the same.
Yeah, well, yeah, let's see how that goes. Because like a height could be like 3 and 3.5 or something, right?
Sure, that's true. We could, yeah, just be safe.
Yeah. Okay. Cool. So we got our two variants.
Mm-hmm.
We have, I think, all the state we need. We have a trailing comma, and I guess let's see if the compiler yells at us.
Okay.
Code. Yeah, that's fine.
Cool. So in the book, they say that you can use an implementation block for enums as well. I think we can just do it like this, right? So I guess this would just have an area method, and it would take self, right?
Yeah.
And then here, I guess, is where we'd have to have like a match statement that does the correct calculation depending on the type.
Yeah, I think we could have a match on self. We just have to then, I guess, implement the arms for circle and rectangle.
Sure. So we can match on self Do I have to use the reference syntax here?
I don't think you do.
Try it. Well, I'm sure the compiler will let us know. So we want to match on shape circle, and we'll do something there, and then shape. Look at that. VS Code has a nice
Beautiful.
fill for me. There. And then I guess we'll handle none, where we can just...
I don't think we need to do that. I mean, I guess it's in case we added a variant in the future, maybe.
Yeah, I guess it would yell it before it even got to this point, right? It would probably yell at you.
I mean, like, because if we implement circle and rectangle, then we cover all the different arms, so the compiler would be happy.
Right.
And then maybe it's actually an advantage to not have it, because then if we added a new variant and we forgot to add it to the implementation block, the compiler would be a buddy.
Right, right. I'm gonna run this and see just see if we got any. Yeah. So it's yelling because I didn't do anything with it, which makes sense.
I think you need some commas after the two arms.
That's true. Do you want to implement the return?
Yeah, yeah, I'd be happy to.
I'm sorry, I forgot. I believe that we should destructure here, right? So we're going to be past a radius, and then rectangle will be past a height and a width.
Okay, cool. All right, I will do the math.
All right, I believe in you.
So because I knew it would come up, I took a note for myself on how to get pi because it's kind of complicated.
Really?
So we have our standard library, and then within, I guess it's the package associated with the 64-bit float type, we have maybe a sub package. I don't know the terminology here for special constants.
Yeah, there's like library, crate, package. I don't know.
Yeah, and so that's pi.
Okay.
Tasty. All right. So if I go back up here to our math equations, pi r squared. So I don't think I know how to do exponents.
You want me to look it up?
Oh, I'm gonna go ahead and kind of do the low tech way,
Okay.
which is just multiplying by radius twice.
No shame in that. I mean, maybe a little shame.
I'm slightly ashamed. Yeah. Okay. So that's circle, I think.
Uh-huh.
Then, thankfully, rectangle is a lot simpler. So. Okay. So, kind of look at the types here. So we are, our input type is like kind of implied based on the type of the enum.
Mm-hmm.
And I guess we kind of pick up the types for these because we're matching on the variance within that enum.
Yep.
But we are returning a value now, 64-bit float. So I think,
Yeah.
like that maybe?
Yeah, that makes sense.
Let's see.
Oops. Huh, That worked.
We actually. Okay. I guess we actually have to do something with it then, right?
Yeah, let's do something.
All right. I'll do the rectangle, and then after that you can try the circle.
Sure.
Yes. So. Let's see. Something like that, I guess.
Nice.
Okay.
Cool.
And then I guess just print out the result, I guess.
Sure.
Okay.
Cool.
Let's try it. Hey!
Wow, first try, nice.
Okay. Yeah, so why don't you do circle?
Sure. I'll steal yours.
I feel like a circle is probably more huggable. It's got
Yeah, for sure.
pointy edges.
All right. All right, and then I'll print it out. All right. Gotta add some semicolons. All right.
Wow, your
Cool.
buddy is much larger than my buddy.
Yeah, a little bit. Cool.
Do you mind adding a comma to the end of line 105?
Sure.
Cool. Okay.
All right. Awesome.
All right, we learned something.
Yeah, we did. That was great.
Yeah.
I feel like
so,
we're getting better. We did that on the first try.
Every week we get a
Yeah.
little bit more practice.
Yeah.
So for the polymorphism example, we haven't learned all the pieces to fully implement it, but basically the next step would be to have a collection of shapes, and maybe we either print the area of each shape regardless of variant, or maybe even sort regardless of the shape variant. Have the biggest thing.
Yeah, for sure. There's a lot of possibilities there.
Powerful stuff.
Cool.
Cool. So what do we have going on next week?
I think modules. That's going to be interesting. JavaScript has a lot going on with modules and how they handle that. So I'm curious to see how Rust does it.
Yeah, I mean, I'm sure anything is probably better than our main.rs file that we stuff all of our lines of code.
Yeah, I'm sure there's a better option out there. So.
Yeah. Cool.
So.
Well, I hope you have a wonderful week, Kait. This is a lot of fun.
Yeah, you too. All right. See you next time.
Bye, everyone.
Bye.